Hello and welcome. Today, we're going to pull back the curtain on one of the most essential, yet kind of invisible, pieces of technology that runs our entire digital world. It's something you use constantly, probably hundreds of times a day, without even realizing it's there.
So just think about it for a second. You create a perfect playlist, you save your progress in a game, you like a photo on social media, you close the app, you go do something else, and when you come back, it's all still there. But how? Where does that information actually go? Where does it live? Well, the answer to that question, the place where all of that stuff is kept safe and sound for you, is something we call a database. You can think of it as the world's most organized, most efficient digital filing cabinet. Now, for our more official definition, a database is a structured collection of data. And the two words to really focus on there are structured and organized. This isn't just a random pile of files on a computer. It's a system that's been carefully designed to find and retrieve information incredibly quickly.
But honestly, if you want an easy way to think about it, it's this. A database is basically the memory of the internet. It's what lets all your favorite apps and websites remember who you are, what you like, and what you've done.
So, okay, if it's a memory, how does it all stay so organized? I mean, how can it possibly keep track of billions and billions of pieces of information without turning into a total mess? Well, it all boils down to a really simple but powerful structure.
At the very core of almost every database is an idea you already know really well. The table. Yep, just like a spreadsheet. It's a simple grid for organizing information.
For example, take a look at this. It's a simple table for storing information about books. You can see right away how everything has its place. All the authors are in one column, the titles are in another, and so on. Nice and neat.
Now, each one of these horizontal lines is called a row. A row is basically one complete record. So in our example, this highlighted row contains all the information for one single book, Pride and Prejudice.
And every row is made up of columns. A column represents one specific type of information. So here we're highlighting the year column. This column's only job is to store the publication year for every book in our table. So you end up with this really simple hierarchy. The whole database holds all your tables. Each table holds a bunch of rows, and each row is made up of individual columns. It's this simple layered structure that is the secret to how databases can manage just enormous amounts of data so well. Okay, so we've got all this data, and it's organized beautifully. But how do we actually get information out of it? How do we ask the database to find one specific thing for us?
I mean, imagine if this table didn't have 5 books, but 5 million. You're definitely not going to scroll through all of that to find the one you're looking for. There's got to be a better way, right?
And of course, there is. We actually talk to the database by asking it questions. And we do this using a special language called SQL, which stands for Structured Query Language.
Now, this might look like a line of code, and I guess it is, but just read it like a sentence. It's literally saying, select the title from the publications table where the author is Charles Dickens. It's a really direct, logical command.
And boom, here's what you get back. The database takes our question, zips through all of its records in an instant, and gives back only the piece of information we asked for. In this case, the title of the book by Charles Dickens. It's precise, and it's incredibly fast.
All right, this next part is where things get really cool. This is where the true power of a database really shines. It's not just about storing lists of things. It's about understanding how those lists connect to each other.
You might be thinking, hey, if tables are so great, why don't we just make one giant table for everything? Put all the book info, customer info, and order info all in one place. Wouldn't that be easier?
Well, it might seem easier at first, but it would actually be a huge mess. Think about it. If one customer bought 10 books, you'd have to type their name and address in 10 separate times. And if they ever moved, you'd have to find all 10 entries and change them. That's just asking for mistakes.
The much smarter, more elegant solution is to keep your table small and focused on just one thing. So you have one table for books, one for customers, one for orders, and then you teach the database how all those tables are related to one another.
And this is exactly how that works. See how we have a customers table and a titles table? They're separate, but they're linked together by a piece of information they both share. In this case, the book's unique ISBN. That link creates a relationship, and it means you never have to repeat information. And that idea is the relational in relational database.
So we've looked at the what and the how, but why does any of this really matter to you? How does this stuff actually show up in your day-to-day life?
Well, it turns out every single one of these things is powered by a database. When you create a social media profile, your info goes into a users table. Your music playlist, that's just a table that links your user ID to a list of song IDs. Your online shopping cart, your saved game, your flight ticket, it is all just databases, working quietly and perfectly in the background.
The big takeaway here isn't that you need to become a programmer. It's just that by understanding these really simple ideas, tables, rows, columns, and relationships, you can kind of start to see through the complexity of the digital world. You can see the simple, elegant order behind what seems like chaos online.
I'll just leave you with this one last thought. The next time you save something or post something and it just works seamlessly, take a second to remember what's going on under the hood, because behind every one of those smooth digital experiences, there's a hidden world of quiet, ordered information.